Hello and welcome. We are discussing PYQs of number system and the theme is digit interchange. We have done two problems already and this is the third one. It says certain three-digit numbers have following characteristics. First, all the three digits are different. Okay, let's say the number is A, B, C, where A is the 100th digit, B is the 10th digit and C is the units digit. Since all the three digits are different, so I have assumed three different alphabets. The number is divisible by 7. Now this number ABC is divisible by 7. Next, the number on reversing the digits is also divisible by 7. If I reverse the digit, the new number obtained will be CBA. C was the units digit over here. So on reversing, C will become the 100th digit in the new number. And this new number is also divisible by 7. Now, how many three-digit numbers are there? So we have to find out the count of all those three-digit numbers that are justifying this condition. Now we know if you subtract two such number, then result obtained will be equal to 99 into difference of the digit that was present at the 100th place and the digit that was present at the units place. This fact has been discussed already in the previous video. If you haven't seen that, kindly go through that video first. Now, at the same time, the original number and the number formed on reversing the digit both are divisible by 7. Now, if you subtract two such numbers that are divisible by 7, then result obtained should be divisible by 7 also. See, 49 is divisible by 7, 35 is divisible by 7. If you subtract these two numbers that are divisible by 7, then result obtained will also be divisible by 7 for sure. So, since ABC is divisible by 7, CBA is divisible by 7, so result obtained should be divisible by 7 for sure. Now, in the result, we are having 99. 99 is not divisible by 7, which means A minus C should be divisible by 7, or it should be equal to a multiple of 7. Now A was the 100th digit, so A should be a single digit number. C was the units digit, so C should be a single digit number. If you subtract these two single digit number, then the result obtained should be a single digit number and should be a multiple of 7. Why multiple of 7? The reasoning is from here. Why 7? Why single digit? Because A is a single digit number and C is a single digit number, and their result should be a multiple of 7. At the same time, it should be single digit number because we are subtracting two single digit numbers. So that is why A minus C should be 7. If A minus C is 7, then the possible values for A and C are A can be 9, C can be 1, and A can be 8 and C can be, C can be 2 and A can be 8 and C can be 1. 9 minus 2 is 7, 8 minus 1 is 7. It means if the number is ABC, then A can be 9, C can be 2, I don't know about B. Okay, and if the number is ABC, then A can be 8 and C can be 1 and I don't know about B. Okay, now I know one thing, and that is ABC was divisible by 7, which means 9B2 should be divisible by 7. If 9B2 is divisible by 7, then if you divide 9b2 by 7, the remainder obtained should be 0 finally. Okay, so let's say how to proceed it. 7 ones are 7, 9 minus 7 is 2. From the above we can drop down b. Okay, then 7, I don't know the value of b, so after it we will get something over here, and we will drop down 2, and finally we should write down such value over here that ends with 2, and if we subtract these two values, remainder should be 0. If we subtract these two values, remainder should be 0. So in the table of 7, tell me a number that ends with 2. In the table of 7, tell me a number which ends with 2. The number is 42. The number is 42. So over here it should be 42. Hence, now over here we should write down such a value so that if I subtract that value from 2b, the result should be 4. The result should be 4. Okay. So see, so this is only possible when you make b to be equal to 5. If you make b to be equal to 5, then the see, 7 3s are 21, 5 minus 1, 4 can be in the answer. So b can be equal to 5. B can be equal to 5. I hope this is clear. B can be equal to 5. Now, if you cross check, you will find out that 952 is divisible by 7. Since we have created this number by following all these conditions, so if I do the reverse, 259, then this should also be divisible by 7. You can cross check. Okay. Now let's justify the next condition. 8b1. This should be divisible by 7. 7 ones are 7. Now we will write something over here. 7 into that thing, we're gonna write down something over here. Then we will pull down 1 from the top. Now 1b, we should subtract something from 1b so that the value that we are getting here should be a multiple of 7. So it is possible when you put 2 here, because in this table of 7 only 21 is present. Only 21 is such a number which ends with 1. So to get 2 here, b should be 6. How come? See, 7 2s are 14. 16 minus 14, you will get 2. So value of b should be 6. So if value of b should be 6, then you will get one more number which is divisible by 7 for sure. 861 is divisible by 7. You can cross check. See, 861. 7 ones are 7, 16. 7 2s are 14, 21. 7 3s are 21. Okay. Now, since we have created this number by following all the given conditions, so if we do the reverse, what is reverse of 861? Reverse of 861 is 168. So 168 will also be divisible by 7. So 952, first such number, 259, second such number, 861 is third such number, and 168 is fourth such number. Hence option B is the right choice. There are 4 different numbers that will justify all these conditions. Okay, so I hope the question is clear. Let's move on to the next problem. This is the next problem. It says the difference between the 2-digit number and the number obtained by interchanging the positions of the digit is 54. We know that if we subtract two such numbers that are formed by interchanging the digits. Okay, so let's say AB is one such number having two digits in it, where A is the tens digit and B is the units digit. Now from AB we are subtracting a number that has been formed by interchanging the digits. Then the result obtained will be a multiple of 9 and it will be equal to difference of the digits. We have done this thing already. So in this first statement, that difference is what? 54, which means 9 into A minus B is equals to what? It is equals to 54, which means A minus B should be equal to what? 6. So consider the following statement. The sum of the two digits of the numbers can determined only if the product of the two digits is known. The statement 1 is saying we can only find out the sum when product of those two digits is known. It is not true. Why? Because if we know the ratio of those two digits, then in that case also we can find out the sum of the digits. Okay. See, suppose the ratio of the digits was 1:2, or let's say it was 2:1. Let's say then if ratio is 2:1, so let's say 2x and b will become x only. So 2x minus x is 6. So from here x will be equal to 6, right? Apart from it, just a second, or a lot of other possibilities are there. This is just an example that to know the sum of the digit, it is not only the necessary condition. We have some more conditions also. If we know the ratios, then also we can find out the sum, because difference is also known to us. Okay, so lot other possibilities are there. So I just tried to explain this with the help of an example. Like, so this is not the valid example, but we can find out the same thing with the help of ratios also. Okay, now the difference between the two digits of the numbers can be determined. So statement 2 is absolutely correct. See, difference of the two digits is, we have calculated it already. So statement 2 is absolutely correct. Statement 2 is absolutely correct. Okay. So I can see option B is the only choice that we have. Okay. So there is one more case for this statement 1 also. See, suppose we can also find out the sum of the digits if one of the digit is known to us, rather than product is known. If one of the digit is also known to us, we can still find out the sum of the digits, because the difference is also there, already there. Okay, so I hope you have understood it. So this is it for this video. We'll meet you in the next. Till then, please take care and bye bye.